Alright, welcome to this first video installment from Alexander here at Sixth AI. Today we'll be focusing a little bit on how to get good quality data from Wikipedia for training machine learning models, and in particular for applications that are looking at natural language processing, chatbots, named entity recognition, things of that nature. And part of the motivation for wanting to do this is I've taken a couple stabs in the past at getting this data and trying to look at what format would be most useful. And good news is that there's a lot of tools and resources to go to. Bad news is that there's a lot of tools and resources to go to. And sometimes it's not always necessarily clear which one to start with. So on this page from Wikipedia, it has some information about the different formats that you might want to use. And one of the punchlines that it has on the TLDR is you probably want a articles multi-stream XML BZ2 file. That for many applications will be what you want. So what I did, and I'll kind of walk you through where I went, how I got stuck a little bit, and then what I ended up doing and in the end. So you can go to this page here. You see some of the different dates that are available, where basically the date given here is the date on which a given dump of English articles was created. Let's take the most recent one, which is from February 1st, and go there, and it has many different files you can download. The one that was recommended under the TLDR section is this one here, this pages articles multi-stream, which is it's a compressed binary file, and this is the index that tells you for a given article at what point in that binary file does the data for a given article take place. So you can go and you can download that file. But once you've downloaded it and then you extract it, you still have a really big file. It's about 80 gigabytes, and it's XML, which a lot of people don't always love XML because getting it to work with different schemas and getting it to parse consistently can be a little bit tricky. There's several different libraries out there which have been put together to help address this. The one which is most common is, or what I believe is the most common one, is a Python library called WikiExtractor. Here is the GitHub repository for that particular library. As you can see, it's pretty popular. It's got almost 1,000 forks and over 3,000 stars. Another one that is less popular but still works well is this plain text Wikipedia, which focuses on simply extracting the plain text with less metadata for each article. And this in turn is built on top of this library. So you have to pip install this Wikitext parser library, which is a upstream dependency. So this is something which was written previously. And then there's other languages besides Python as well. Here's one written in Scala, which, to be honest, reading some of the documentation looked pretty elegant, but I've never really used Scala much, and so this probably would have been a bit much for me to bite off for my first ever time jumping into Scala. So what I did is I'll walk you through a couple of things that I tried and where I got stuck a little bit and what I ended up doing as a workaround. So first I tried this library here, the WikiExtractor, because it is the most popular. And what it does is you basically give it as a command line argument. You execute the Python file, and then give it as a argument the path to the extract that you want to parse. And it's got some arguments that you can set, for instance, the output file, and then I also set this this JSON flag. So when you do that, what you end up getting is something that looks like, let's see if I can find it now. Here, something which looks kind of like this. So here is the compressed file, again 22 gigabytes. Here is the extracted file. It's an XML file, almost 93 gigabytes. And then the extraction process will go to the folder that you select and will spit out all of these subdirectories. Each one of these will have 100 files in it, each right at a megabyte. And each one of those files, if you open it, will have a JSON for several different articles. And here I've gone in, and this is a Python shell, and so I have gone in and I have taken a look at one of those files, and things look pretty good. The text looks pretty clean here, but one thing which is maybe a little bit interesting is you also have links to some of the articles which are linked in Wikipedia. So you'll see in some spots it has a double square bracket, and that will indicate a link to a different Wikipedia article. One thing I don't like, however, is if you go into the bottom here, this is just one file. So, for instance, this is parsing the raw text from the AG folder, one of these folders as an example. One of the files, so the wiki_37 file, and for several of these, it has no text here. The text is blank. So with this one as an example, if I go in and I open this article, I suspect that probably that article isn't actually blank. There is some text there. And look at this one. This is an article about computers. Clearly, this is a fairly lengthy article. There is text there. So one of the challenges here is that the extraction of text looks nice and clean for most articles. It preserves some links to other Wikipedia articles, but there seem to be a somewhat elevated number of articles where the text is blank, which, depending upon how rigorous you want to be, that may not be a deal breaker, but it is one potential downside. So I tried that, and here I've had it running for about 18 hours or so, and each time it whimpers a little bit. When it has an error with one article, you'll see something like this, but the command to get it to parse all of those was simply just this Python wiki extractor, then the directory, the file name, I set the output, and then the JSON flag. So that's what I was running. In 18 hours, it's generated this many subfolders. It's got a ways to go, because to get to the full 80 gigabytes, give or take, of output, it's not there yet, but it's on its way. So because I didn't like these articles with missing text, I also tried this next repository here, the plain text Wikipedia. So this one is a little bit different, where you actually end up cloning this repo, and then it suggests that you go into this file here, wiki2text, and you manually replace the path for the XML file that you'll be parsing, and then the path to the output directory that you want to use. So it's really pretty simple to use. You have to pip install a couple dependencies, one of them being this wiki-text parser, and then you edit this file, and you run it. And I've been doing that here in this window, and it gives a nice output to the text in that it seems to have almost all the metadata removed. It's a very easy to read output. The one thing I don't like about it is that every single article gets its own file. So by the time this finishes, it should be probably around, I think, 6 to 10 million articles, give or take, which makes it a little bit unwieldy to navigate that folder. And then you have to also go and open each individual file if you want to get the text from it. So it doesn't have all the features of the wiki text extractor, but maybe it does a better job getting the full body of the text. So there's some trade-offs there, but I don't particularly like having one file for each article. So that's what I had looked at so far. But then I noticed one third approach, and that was actually here in one of the comments within the original wiki extractor repository. It mentions that it has a separate file that performs extraction from a Wikipedia service dump. Now, I don't have a lot of detail on this particular type of a dump. I think based on the documentation that I have read, it was an attempt to put some code together, largely sponsored by Wikipedia, that would be an easier format to ingest for an Elasticsearch type application, which is a good thing. I mean, for what I might like to do myself with the data, that seemed to be in the right direction. So as an alternate approach, and this is where I ended up ultimately taking things, is I went to this page that has the list of the source search dumps by date, pick the most recent one, and then went down till I could find the English Wikipedia article set, and I did this one here. So the English Wiki, February 6th, source search content, json.gz. That's the one that I downloaded, and by the time you extract it, it is a pretty big file. It's around 150 gigabytes by the time you extract it. So it's a very lengthy file, but having done that, it was there ready to use. Now the problem that I ran into is when I tried to use it, I went over onto this machine here. So here, this is a separate machine where I downloaded that file. And the challenge that I had here is when I tried to go and extract it, things did not work the way that it was supposed to. So I extracted the dump file, but the issue that I had was when I ran it with the same arguments that are provided in these examples here, the output file ended up never having any content in it. So maybe if someone who has more familiarity than me can point me in the right direction, maybe it's user error at some point. But ultimately, I tried following this path here and using this file, and I got stuck again. One thing that I did notice, though, is that the output from this file here looked a lot cleaner and neater and like an easier to parse JSON type of output. So that's what I thought, this is what I'll want to go and work with. And I started writing a library that works specifically with that type of a file. And so here, let's go over to an editor here, and we'll look at this repository. So this is a only partially finished piece of code. I'll do a bit of live coding and maybe clean this up a little bit here, and then post a link to the more finished version of the Git repository here in the notes to this show. So what this file does is you provide an argument, which is the link to the JSON file. And again, remember, this is about a 150 gigabyte file. And then it will read it line by line. It does that so that you're not reading the whole thing at once. You don't use too much memory. And for each row, you will parse it as JSON. And so something here kind of interesting happens. Let me make it pause after each row so we can see what the output of that file, what the contents of that file are like, I should say. So here I have I've put in as the file name the path to where that JSON file is. And when I go and I start to read the file, here's the first line. I'll hit enter. It's going to read the next line. Oh, sorry about that. I think trying to stop and interrupt reading a file that large actually ended up being a little bit taxing on the disk, I think. So I've gone here now to just having a list of rows and appending it just so we can inspect some of the output. But I'll go through and start reading these rows. And if you look at the very first row in the JSON file, it looks like that. The next one looks like this, so it's this nice kind of cleanly formed JSON. The next one looks like this, and the next one looks like that. So what it looks like is going on here is that all the odd numbered rows are simply something like this that says, this is an Elasticsearch type JSON saying with, this is a document, here's the document ID, and the document follows below. So basically every other line of this file, which are the big lines, are the ones that contain the information for that article. Now in this code here, what I have it do is for each row, I have it parse the row as JSON. So just simply JSON, loads the row, return that as a dictionary, and then I want to see how consistent is the metadata, how consistent are the fields from one file to the other. If there are fields which are present on almost all documents, then I would want to expect that perhaps and have it be a property which I will force the document to have, and if one of them is missing it, maybe I skip that row. In contrast, if there are properties which only say half the documents or 70% or 5% have, maybe that's a property which I will include as a optional type where it could be included, but if it's not there, I don't want to have it throw an error. So let's run this, and to count that, I've initialized a dictionary and I've called it key count, and for each time that it comes across a document, it will increment the count for that field by 1. So what this looks like is I'm going to let this run for a little while till it gets to process a few documents, and again for each document that it finds, what it's going to do is it's going to look at the fields that are present, and for each field it'll increment the counter for that particular field. So now let's look at key count. I've paused it. It's gone through 50,000 rows, which should be about 25,000 documents, give or take. And so it looks like we processed 29,013 documents because many of the indexes many of the fields appeared that many times. So this is encouraging. It looks like almost all of these fields here appear across all the documents. A few of the exceptions would be default sort. That field looks like it appears on roughly 40% of the documents. Here, this Wikibase item, that one appears on almost all but not quite all of the documents. version type that appears on basically 27 of 29,000. So this is what I mean in that I want to be able to define a class type that will be a Wikipedia document, and I want to determine which fields are mandatory, in that if a document is missing one, I choose to skip it, and which ones are optional, where if it's not present, I simply have it be an option, knowing that it's not going to be there for all the articles. So this is encouraging. I also here took accumulated a list of some of the documents. So if we do docs, and let's just pick one as an example. Let's pick the 20,000th doc. This is what it looks like. Let's look at the keys. Let's look at some of the key ones you'll want. Let's see the title. Okay, and let's see the text, and this will be a quick sanity check. Okay, we've got some text. This looks like it's pretty clean English. I don't see lots of HTML or XML markings in here. This looks pretty clean. And there's a few other interesting things here as well. Like we've got this category. Let's see what that is. Okay, so this is a list of different categories. So this would be like lists of football players, lists of soccer players. This is the context in which you've got different categories. So there are several categories this article could fall under. So it looks like we're making some progress here. So we now know how to go and open the file, read it. Every other line corresponds to a document. It looks like it's been parsed as JSON pretty reliably. We'll still want some error handling because there may be occasions when something goes astray. But by and large, I mean, we just did 50,000 documents without a single hiccup. And so that tells me that the percentages of errors should be, at most about 1 per 50,000. That's pretty good. But we want to define this in a way where we can make this portable, so that depending upon what you want to do with this, maybe you want to dump it to a plain text file, maybe you want to put it in Postgres, maybe you want to put it in Elasticsearch, whatever you want to do. We want to make this portable. So we're going to define two separate classes here, and that'll give some structure that can be imported from this library to something else, and then we'll end up deleting all of this code here that kind of goes and does things manually. We'll want to encapsulate all that. So let me first define a class called an article. And I'll make this a bit bigger in the final version of the code, but let's just capture a couple key things for now that we might want to include based on the output we saw already. So let's go back to the key count here. So let's do the title. That one will be an important one to have. And what I'm going to do is, when I initialize one of these articles, I am going to initialize it using the JSON output that came from the dictionary, meaning from this parsing the JSON here. So I'm going to have one input argument that's going to be the JSON, and that will be a dictionary with string keys and object outputs. And I will have self title, that'll be a string, will be the title key, the title value, And let's do one other example here. Maybe let's see what's this. Let me take a look at what's this one here, the Wikibase item, because this is one that's interesting because it's present for most but not all. So let me take a look at the Wikibase item. I don't know what that is. But I'm going to include it here as an example of how we'll want to capture fields that may or may not be present. So for this one, I will put self I need to include the optional type from the typing module. And so for this one will be the JSON get the Wikibase item, and if it's not there, just return none. So there's other fields, and in the final version, I'll probably have one field for almost all of these, or at least for many of these keys here. But this is enough to kind of get the idea. Now I'll want to define a second class, which will be the reader, basically. So I'm going to call this class WikiEnGine, and to initialize this, we'll need to provide a path to the file that we're going to be opening. So we will set self, then we'll want a handle to read that file. So self.h equals open the file in read-only mode. And now we'll want to make a method for this which will yield the next document in the file. So the way to do that would be we'll define a function, we'll call it next, and this is going to return one of a new article, this will emulate the loop that we had below. So we'll choose row equals self h read line, and then we'll say if not row when it reaches the end. But instead of doing return, we're going to yield. We're going to make a generator. And then we'll parse the JSON. And if, I'll say if not title in the JSON, that means if we get one of the rows that was like this one, where it's just the index, if not title in JSON, continue. And then finally at this point, we know that it's one of the rows that has an article, so we will yield article JZ. So this, I think, may work. I probably made a mistake here someplace, but we'll be close enough to try here at least. Okay. So if I echo, so this is what the file is that I'm using. So let's do this. So I will simply let me open this and let me set file equals name of that file, and now I'm going to instantiate the engine. Now let's see what happens if I call next. This might actually be working. So let me set let me call this an article, and I can then do things like article oh, I've made a mistake here. Sorry, I made one mistake there. It's been a minute since I worked with a generator. So the syntax here is we instantiated the WikiEnGine. The generator, the next method returns a generator. So the way to use it is to say for article in WikiEnGine next print article title as an example. So this is going to give a generator where we can have all of the articles and then print the title for those articles, and we call that, here we go. So now it's going through the JSON file. It's reading it one row at a time. When it gets to the end, it'll simply yield none. In the meantime, it'll parse each row as JSON. If the JSON doesn't include the title field, it'll skip that, then it'll go on to the next one. If it does have the title field, it'll then yield an article. It instantiates that article by feeding that JSON dictionary as the one sole argument to the article class that upon instantiation includes the title, the text, and the optional Wikibase item. So that's the shape of something which, to my mind, it runs reasonably fast. It has reasonably low memory consumption because you're only reading one line at a time, not the whole file. And it looks like it's running, relatively smoothly here. So what I'll do here, after we stop the recording, I'll go and clean up a few more of these fields so that this is a little bit easier to use, and you've got the the full set of metadata basically. But then this will be available as a repository, which will be an alternate way to get the text from Wikipedia files for all of your machine learning needs. Alright, thanks for watching. Kind of a longer video today, but appreciate the time. Hope that this is useful. We'll talk again soon.